a reference angle. I mentioned the term before, but let's go more into that because I said that like for instance like angles like a 30-degree angle, the 200 and no, sorry, the 150, the 210-degree angle, the 330-degree angle all have reference angles that are 30 degrees, and that's why they all had a denominator of 6 when I had them in radian form. Let's talk about a reference angle. It's a reference angle is defined as a positive angle between 0 and pi over 2 drawn between the x-axis and the terminal side of an angle, or terminal ray, I should say, really. So in quadrant 1, the reference angle would be the angle itself, okay? The angle in standard position, that is. When I'm in quadrant 2, the reference angle is going in that direction. Notice I put the direction there, it's still going counterclockwise. It has to be a positive angle. It's not saying it's a standard position anymore. It's just saying that it's between the terminal ray and the x-axis. In quadrant 3, this would be the reference angle, and in quadrant 4, this would be the reference angle. The reason why reference angles become important is because, one, when we start dealing with situations where our angle measurements, because we often use um, triangles, right triangles for that matter, to be references or to reference how we're going to calculate the sine, cosine, tangents, and all the other trig function stuff. So, the reference angle will often take the place of an angle that's more than a 90-degree turn. Okay. Because if I'm going to use right triangles as a reference, well, I can't have any angles more than 90 degrees in a right triangle. So, and I can only have one right angle inside there. So usually the angle I'm looking for I'm going to be using its reference angle if it's above 90 degrees. The other thing about reference angles is that when I go and start looking into those trigonometric functions again, if I know angles have the same reference angle, then when I look at their sines, cosines, and tangents, at least the number portions will all be the same. Whether they're positive or negative, that's going to matter on which quadrant they're in, and we'll talk more about that decision-making process as we draw closer to that. So, special right triangles. Now, you've learned about these special right triangles in different forms, and even these special right triangles have shown up on SATs and other standardized tests that you've more or less taken. I mean, even I believe students who have taken PSSAs or keystones have seen these triangles show up on their formula sheets on those too. For the time being, the way we're going to look at this on a unit circle. I mean, so in each one of these, the hypotenuse of these right triangles are going to be 1 because we're talking about a unit circle, radius of rotation 1. We're used to seeing it like this. Okay, that I have, for looking back to our SAT days. The S always stood for the shortest side, and the shortest in a triangle, the shortest side is always opposite the smallest angle. The hypotenuse should be twice that amount, and the side opposite the 60-degree angle should be the square root of 3 times the shortest side. Well, if I'm going to let 2s equal 1, because that is the radius of rotation, that means that s is going to equal 1/2, in that s times the square root of 3 is going to be the square root of 3 over 2. So the ratio of sides I have on a triangle like this, if it's based off a unit circle, is going to be 1/1/2 and the square root of 3 over 2. When I go and look at a isosceles right triangle, or also known as a 45-45-90 triangle, again, the shortest side is s. The hypotenuse is always s times the square root of 2. But now if we're looking at the hypotenuse as being 1, then s is going to be 1 over the square root of 2, which we will usually rationalize that denominator and say square root 2 over 2. Now these are numbers you're going to start seeing a lot when we start talking about the trig functions. Okay. So these numbers are going to be seen a lot as we start talking about these trigonometric functions. And if you start seeing these numbers, and you're talking about angle measurements, if I see a square root of 3 over 2, for some ratio, I know either a 30 or 60-degree angle is going to be involved. I start seeing square root 2 over 2's, I'm going to start thinking 45-degree angles, that sort of thing.